Current, electricity. Electric current. In the previous chapter, we studied the behavior and the effect of electric charges supposed to be in stationary states and came across with forces between charges, the electric potential. From this chapter onwards, we shall remain concerned with the study of the properties and effects of electric charges when they are in motion. This field is known as electrodynamics. The first thing which comes to our mind in the study of electricity is the generation of electric current, which we shall show as the rate of motion of charges in a conductor. The best conductor are metals, particularly silver, copper, gold, aluminium. In these metals, the electric charges can flow very easily. In metallic conductors, there is always present a large number of free electrons actually detached from their parent atom, which constitute a kind of electron gas. These free electrons are capable of moving freely in random directions in the interatomic space of the metal. In insulators, the electrons are rigidly bound to the atoms and so cannot move, and hence no current can flow through them. In the absence of an electric field across the conductor, the free electrons have a thermal velocity at normal temperature, which is of the order of the millions meter per second. The velocities of these electrons are randomly detected, and in effect the number of electrons moving in one direction is just equal to the number moving in the opposite direction to maintain the neutral state of the conductor. On establishing an electric field between two ends of a wire by applying a potential difference, these free electrons, having a negative charge on them, experience a force in opposite direction to the field, and hence acquire an acceleration in that direction. These free electrons, which in the absence of electric field were moving towards the positive terminal of the battery, are now accelerated, while those moving away from the said terminal are retarded. The net effect is that an additional component of velocity towards the positive terminal is superimposed on the free electrons over their thermal velocity after they suffered a certain number of collisions with the atoms. This additional component of velocity due to the electric field is known as drift velocity. The magnitude of this velocity is of the order of 0.01 meter per second. This drift velocity in the free electrons is really responsible for the generation of electric current in the wire. Thus, we see that electric current in the conductor is due to the flow of electrons. We define the strength of current in a conductor as the number of coulombs of charge which pass any section of the conductor in 1 second. Hence, if a charge of q coulombs follows through a section of the wire in times t second, the current I through it is given by the relation I is equal to q over t. The unit of current is 1 coulomb per second. This unit in SI is called as ampere, after the name of the French scientist André Marie Ampere. The smaller units of current are milliampere. MA is equal to 10 minus 3 ampere and microampere. UA is equal to 10 minus 6 ampere.